Okay, so today we'll be testing the Caesar cipher using the sokonalysis tool. So in case you want to get a copy for this tool, sokonalysis, if you're in campus, Kapasa, Makasa University, you can simply visit me, then I'll give you a copy. But for the sake of downloading it online, it will be available soon. The link will be attached in the description. So without wasting much of our time, let's see some of the questions we'll be looking at. So basically this is the new update for the tool. I'm actually calling it sokonalysis version 2.1 for now. Yeah, so let's see. So here we are trying to look at the Caesar cipher. So we have a question from Cryptography 2023 test 1 for Kapasa Makasa University, done by Mr. Chiara. So using a Caesar cipher with S equal to 5, decode the received message, which is this. Okay, so here what we need to understand with 2 is that since we have symmetric algorithms where Caesar cipher has 4 because it uses the same key to encrypt and decrypt, we'll say 1 for symmetric algorithm. Then under symmetric algorithms, we can see we have Caesar cipher itself. Okay, so again we're going to say 1 for Caesar cipher. Then here the question is just telling us to say it as a shift of 5. So this is a basic shift Caesar, so we're going to say 1 for that. Then here we are told to select the letter to number mapping style, so I'm going to use A1 to Z26. So I'm going to say 1. Then now we are told to press E to encrypt or D to decrypt. So the question is telling us to decode, so I'm going to say D to actually decode that. So enter the message to decrypt, so I'm going to paste that in cipher. Then I'll make sure that it has no spaces in between. So once you do that, just need to press enter, then enter the shift value for which we are told is 5. Okay, so we're going to say 5. Then we can see that our decrypted message is this test is interesting. Okay, so we've obtained our first plain text. So go to the next question, which is actually B. So using a Caesar cipher with S equal to 3 and S equal to 7, encrypt the message welcome to cryptography using this sequence. Okay, so here because we have more than one key, we have 2 keys, it becomes a polyalphabetical cipher because not only one key is involved, okay, but 2 or more, in our cases 2. So remember, we'll start with symmetric algorithms, which is option 1 for a Caesar again. Then we're going to say Caesar cipher, so we'll say 1. Then here we are going to go with option 3, which is polyalphabetic cipher. So after selecting that, here we are interested in option 3, which is polyalphabetic cipher, which is actually a sequence based. Okay, because here we are given the sequence. Okay, so what we do is that we are going to select option 3 for sequence based. Then we are told E to encrypt, D to decrypt. So here they are telling us that actually we need to encrypt that message. So we are going to say E to encrypt, then enter the number of keys. Here we are given 2 keys, 1 and 2. So we are going to say 2. Then enter the shift value for key 1, for which is 3. So we are going to say 3. Then enter the shift value for key 2, which is 7. So we're going to say 7. Then here we are told enter length of key sequence. So if we can count, this is 1, 2, 3, 4 and 5. So our sequence is 5. Then enter the sequence space separated indices starting from 0. So what we mean is that since we have our first key, which will be represented as C1, then our second key, which would be represented as a C2 or cipher 2. So here, since we are starting at 0 when counting, we are going to consider the first key as 0 instead of C1, and we are going to consider the second key as 1 instead of C2. So C1 becomes a 0, C2 becomes a 1, C2 becomes a 1, C1 becomes a 0, and C2 becomes a 1. So that's our sequence. So we're going to say, since we have C1, we are going to say 1, then we put a space. We have C2. Oh, by the way, we have C1, we say 0, then space. We have C2, we're going to say 1, space. Again, C2, 1, space. Then C1, which becomes a 0, space. And then the last one, which is actually C2, which is a 1. So if we see our sequence was 5, if we count, it's 1, 2, 3, 4, 5. Then you press enter, and then enter the text you'd like to encrypt, since we've said it to encrypt. Okay, so we can see the text you're entering is welcome to cryptography. So I can just type that, welcome, then to cryptography, welcome to cryptography, like that, then enter. So you can see this is our cipher text. Okay, so for the sake of proving, let's just decrypt this with the same information. So why to go back to the main menu, then remember we started with symmetric algorithm. I'll say 1, then we went for Caesar cipher, which is actually 2 or 1, then we went for polyalphabetic cipher, which is 3, then polyalphabetic cipher sequence based, which is 3, then here we want to decrypt, I'll say D, then enter number of keys, if you can remember it's 2, then the shift value for the first key is 3, followed by 7, then the length of our sequence is 5, then our indices, we said we have C1, which is a 0, then C2, which is a 1, C2, which is a 1, C1, which is a 0, and C2, which is a 1. So here we enter the cipher text which we had obtained. Then once we press enter, we can see that the decrypted message is welcome to cryptography. So it means we have successfully answered that question. So now we have question C, which says the centurion who was supposed to inform you of S was killed in the route, but you have received the message, which is this. Okay, in the cipher. So they're saying in a cipher, Caesar cipher. So find S and decode the message and use brute force. Okay, so here remember we are still under symmetric algorithms. So we're going to say 1. Then we're interested in Caesar cipher. We're going to say 1. Then here we are interested in brute force Caesar. Okay, so for brute force Caesar, we're going to just say 2. Then here I will again choose this mapping style. Okay, then here they're telling us to enter the encrypted message, which is that. So remember, we don't need the spaces. I'll get rid of the spaces. Now for a brute force, we are assuming that we would like to know all the possible keys, okay, which might decrypt this particular message. So we don't need to enter the key there. We just put the cipher text, then enter. So they are telling us to press any key to continue. So you can see shift 1, this is not making sense. I'll press enter. Shift 2, this is not making sense. Enter. Again, shift 3, shift 4, no sense there. 5, 6, 7, 8, 9, 10, 11, 12. So for 12, you can see that here it's saying O gal is divided. Okay, so there we can see that actually this is making sense. So this becomes our decrypted message. Okay, or gal is divided. So there we can see shift 13 doesn't make sense all the way to 25. Okay, the last shift. So since we are done, here this was the previous logo for sokonalysis. You can see it has changed to this. So the last update was made on 8th June. So today I'm recording this video on the 9th, so just a day ago. So yeah, basically let me just walk you through one video or one tutorial under symmetric algorithm where we're going to say 1, then again we go to Caesar cipher, then here we are going to go for polyalphabetic cipher, which is 3. Then since we haven't demonstrated this one, such as polyalphabetic cipher keyword based, so I'm going to say 1. So here we'll choose the mapping style, which is any of these, so I'll go with 1. Then let me just encrypt something, I'll say E. So enter the message I'd like to encrypt, I'll say Soko James. Then the keyword I'll just say SO, okay? So we can see this becomes our encrypted message or cipher. So how does this even actually work? So for us to understand this, let me just put on my notepad. So how that actually works is that we need to have a plain text such as this. Okay, we need to have a plain text such as this from A all the way to Z. Then our keyword we are saying is SO, which is so. Then this is the normal alphabet we know from A to Z, our plain text. Okay, then since our first letter on the key is S, we're going to see that S is starting from here. Okay, so starting at S all the way to Z, this is where our shift to start. So we can see that here our first shift is starting at S all the way to Z, then we are wrapping around the alphabet again all the way to A, to the last corresponding letter to Z on the plain text, which is R. Okay, so the next letter here we have O. So we can see that O is starting here, then all the way to Z. So we're going to get this part and start at O all the way to Z. Then again we wrap around, or we start afresh from A all the way to N, which is the corresponding letter to Z. Okay, so once we come up with this thing, actually how we get this ciphertext, we're going to paste the plain text, which is Soko James. Like here you can see Soko James. Then since our key is SO, the first letter we're going to say S, then O. Again we repeat it, S, O, this is our key. Again S, O, again S, O, then here we say S because we don't have the last letter, say O. Okay, so here we'll be doing like this. Since we want to encrypt the word S, which is actually the plain text, and they're telling us it must use the key which is S. So for us to encrypt this S, we need to go where there is S. So you can see S is K because this shift was for S, this first shift. So our S becomes K. No wonder you can see K, and there you can see K. Okay, then O on the plain text, which is this O, they are telling us to go on the key of O, which is actually this key for O. So O becomes C on this key. You can see there is C. So that's the way we are encrypting these things. Okay, so at least you've gotten maybe the concept there, but my goal is not to teach you manually, but use the key. Okay, so let's see if we can actually decrypt this. So I'm going to get this, then I'll say why to continue. So remember, we'll go with symmetric algorithm, then we're going to go with Caesar cipher, which is 1, then polyalphabetic cipher, which is 3, then polyalphabetic cipher keyword based, which is 1, then mapping style, we're going to do that, D to decrypt. So the message would like to decrypt is that, then the keyword was SO, then we can see we are getting back Soko James. Okay, now let's see the last example. So go back to symmetric algorithms, then we're going to say Caesar cipher. Okay, then we're going to go with polyalphabetic cipher, which is 3. Then here we're going to go with Vegenere cipher, so which is just similar with the previous example. So let's just encrypt something. So here we are just recommended to use uppercase. Maybe we can say welcome. and then the key again in uppercase, maybe we can just say oh hi as our key. Then we have this as our encrypted message. So just get this, we try to decrypt, we see how it works. So we are going to repeat back the steps. So 1 for symmetric, 1 for Caesar cipher, 3 for polyalphabetic, 2 for Vegenere, D to decrypt. So here we are entering the message you'd like to decrypt, then the key which is I, then you can see welcome. Okay, so there we are done with this presentation for Caesar cipher. So now imagine if a user didn't have any knowledge about Caesar ciphers, they can request for help, which is option 8. Then here they'll be just pressing enter or any other key till they reach on Caesar cipher. So here you can see we're saying a Caesar cipher, a substitution cipher where each letter of the plain text is shifted by a fixed number. So here we are given an example where we have this letter to number mapping of 1 to 26. Then our plain text from A to Z. Then there are the shift of 3 because these letters were gotten rid of, then they started at D all the way to Z. Then the same letters which were getting rid of were wrapped around or added at the end. Okay, so that's how it works. Then if you want to encrypt something just such as hello with the shift of 3 to get this cipher, what they are doing is that, okay, since here we have H, we'll say H becomes K, that's the K. Then we are saying here we have E, so E becomes H, that's the H. Then here we have L, so L becomes O, we have two L's, so becomes double O. Then the last one, which is R, becomes or which is O here, which is, where is O, which is O becomes R, which is that. So that's how a Caesar cipher works. And then I'll press just enter. Okay, so here you can see we have a brute force cipher. So you will be having a shift from shift 1 all the way to shift 25. So here we are trying to brute force each and possible possibility for each shift. Okay, so for example, you can see that if we are not given this key which is 3 for us to get we have just this cipher, then we are not given this plain text which is 0 for us to brute force it. We can see that on the shift of 3, actually if we go where there is H or where there is K, we know that since K is found on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then here we have 11. Okay, so here what I'm trying to do is that for us to get back this same thing, such as maybe K becomes H, you can see that on K it's becoming actually H. So if we just count where this H is 1, 2, 3, 4, 5, 6, 7, 8, then we can see that, okay, since here is our K, so if we count 1, 1, 2, 3, 4, 5, 6, 7, 8, that's our key. Okay, so on the alphabet, if you're saying A, B, C, D, E, F, G, H, that becomes H. So for us to know what this H is, we're going to say A, B, C, D, E, which becomes E for arrow. Okay, so for us to get this L, we are going to say A, B, C, D, E, F, G, H, I, J, K. Oh, for us, by the way, for O to get this L, we're going to say A, B, C, D, E, F, G, H, I, J. We have what? O. Okay. So here we have A. So, oh, by the way, I was reversing this thing, okay? So here we have O, and here it's becoming L. So we can see where there's O, it's becoming L. So by the way, if you just get this, then you use it to brute force, you're going to get everything. So assuming that you don't know the keys there. So the user can understand this through the menu, then they can see how a polyalphabetic cipher works. So for this one, I had explained, so using the notepad, but you can also get the concept from here. Then again, how the Vegenere cipher works, actually similar to this same polyalphabetic cipher. So you can just go through this, then you understand. Then at least for Caesar ciphers, someone could understand. So this is Soko James. So thanks for watching, and hoping to see more videos on these two sokonalysis. So you can comment below to see uh, what changes I can add, what improvements we can actually work on this particular tool. And if you have any questions on how to access maybe this tool before it's published, if you're not from Kapasa University, you can just reach me out, then maybe I can send the files through email or WhatsApp. Thank you.